Is momentum a force in motion? We use the conservation of momentum law to better describe the momentum in a moving body with a force acting. Generally, momentum is a factor that decides the mass of the body that will have to be altered when the body's speed is changed. For instance, if we consider a car moving forward in the same direction with a constant speed, it will have a forward force. The forward force can be equal to, less than, or greater than the backward frictional force. This backward frictional force is one of the reasons that the car keeps moving in motion on the road. The frictional force keeps the car active in motion despite the kind of surface it is moving on. The net force on the whole system is equal to zero if all the forces acting are balanced, and that will reflect on the system as well. The velocity will still be constant, and in turn, the acceleration becomes equal to zero, as there is no change in speed with time given. If the engine speed is increased, the car will keep moving in forward direction, and if the engine force decreases, the car will experience a backward force. Frictional force comes in handy to help out this backward force and slow down the vehicle if needed. The momentum is basically the determination of the quantity of motion of the body, and how hard it is to stop that body under motion. A few examples help us better understand if momentum is a force. Real-life concepts to understand: is momentum a force in motion? Consider a cannonball that is used in firing. Image: if the ball is made up of a wood, then the ball's motion can instantly be stopped soon after firing. But it is made up of a metal, then the motion cannot be stopped, and is very difficult to even think about ceasing its projectile motion. We have already dealt an example of how a car moves with the given speed, and now once again we shall consider the same example. If the car moves in the forward direction with constant velocity, and due to application of brake the velocity will undoubtedly go down. The kind of understanding we make from this is when there is a decrease in velocity, there will be changes made within. And one of those is velocity, momentum, impulse, and so on. So now that velocity has been decreasing, the direction of force must be determined, and the momentum. When velocity decreases, the forces will act in a backward direction opposite to the car's motion. Only when the forces act backward will the car ceases. But the momentum will be in the direction parallel to the car's motion. From these examples, it is visible that momentum can be a force that acts in the direction of the car's motion. Momentum will be the change of mass in terms of speed, and explicitly, it will contribute to the system in ways that force that will not be able to. Why is momentum not a force? We can determine that momentum cannot be a force from the very own formulas of force and momentum. Momentum is the product of mass and velocity, but force is the product of mass and acceleration. Although acceleration measures change in velocity with time, acceleration cannot become velocity. Likewise, momentum cannot become force. We know that there are laws for conservation of force and energy, but not one such as conservation of force. Momentum is regarded as the measure of how hard it is to stop a fast-moving object, and the ability to start the body lying at rest. When an impulse force is applied, the momentum will instantly change according to the speed of the body undergoing motion. Also, momentum is directly connected to mass and velocity. Likewise, when these quantities change, there is an instant change in momentum, but not in force. In the system considered. For instance, in an elastic collision, we know that energy and momentum are the two essential factors or quantities that supposedly contribute to the motion or collision. There is a conservation of the momentum and energy in an elastic collision due to the values being zero or non-changeable. Momentum versus force. As we all know, there are many differences between a force and a momentum. So force is an action on the object that will result in the start or stop of the motion in a body. And momentum is the measure of how much motion has happened in a particular system. Force acts in the direction of acceleration since it has the formula, that is the product of mass and acceleration. Momentum acts in the direction of velocity due to its formula, which is the product of mass and velocity. Considering time in both momentum and a force, it has different aspects that provide to the body's motion within and outwards. So when we increase time, the force will eventually decrease only provided the system's momentum is kept a constant throughout that particular time. When the time increases in a particular system, the momentum will also increase to help the body to move in pace with the changed speed. The motion is directly proportional to the momentum, and when there is a decrease in velocity too, momentum will act in the same direction as the motion of the body does. Force is actually the result of physical changes in a particular body or object that is under constant motion. When the force is applied to a system that is under rest, it will get into motion at once, analogous to it is for the body under motion. When we make sure that an external force is applied to the system that is under rest, will at once, and it will stop if it in the process of motion. How is force related to the momentum of a body? Generally, coming to talk of the force applied to the body under motion, there will be a change in momentum in the direction of the applied force. Usually when a vehicle moves in a particular motion, will have a certain velocity with which it will drive forward. This velocity will be a constant unless there is need to change the speed according to the necessity. We must apply external force to change the speed. That force can be named as impulse force, which will result in the change of momentum. So finally, we know that when a force is applied, there is an instant change in momentum. In this way, is evident that force is directly related to the momentum of a body that is under constant motion. So the rate of momentum change is also due to the application of external force. Also, there is one central aspect to look. When an external force is applied to the system under motion, the end result will be there is no momentum conserved in that particular system. How does force affect momentum? Is it a known fact that we need force to do any action in terms of physical thing? So when we apply force to a particular system, there will be no conservation of momentum. When there is force acting on the body under motion, the momentum will undoubtedly change. In collision of particles, it is an actual fact that force plays a significant role contributing to the non-conservation of the momentum. In fact, there will be a minimal amount of force within the colliding system, which is why there is movement happening. Kinetic energy is required for the particle to move and collide with each other. With the kinetic energy, the particles are free to move and contact each other. This energy is sufficient for the motion, and momentum will also provide for its change in speed. So the force affects the momentum in not being able to conserve itself in an isolated system where two colliding bodies are in action. Is angular momentum a force? Angular momentum is the momentum that is termed with the rotatory body or circular motion of an object. When we say that there is momentum in rotatory motion, it is termed with angular momentum. Force is a term used for linear motion and not for circular motion. We call it torque if it is a circular motion. So when external torque is acting on the circular motion, the angular momentum is usually not conserved. When we consider the circular motion, we call the momentum to be the angular momentum. The angular perspective of the rotatory body or circular motion is named as angular momentum. Torque plays a significant role in aiding the motion of circular. So the internal torque is more than enough if the angular momentum is conserved. We must know that the formula for angular momentum is the product of angular inertia and angular velocity, which is analogous to the linear momentum having formula as the product of mass and velocity. In this explanation, nowhere does the concept of force is considered. Force is a distant entity that has the formula as the product of mass and acceleration. And we know that force is definitely not related to the angular momentum. Is linear momentum a force? Linear momentum is simply the momentum itself, analogous to the angular momentum. So when we talk about force, it is indirectly related to the linear momentum as such. The momentum is the result of a specific change in the system when an impulse force is applied to it. So when there is external force acting on the system, certainly there will be chance of conservation momentum. Let us use an example to understand this better. We use a car that has a mass of 2,000 kilograms moving with a velocity of 7 meters per second. What will be the momentum with which the car is moving forward? The answer will be 14,000 kg/m/s. From this we can tell that the car has a significant amount of momentum, and the force is nowhere related, and even if so it will be less than the value of the momentum. It is easier to determine the momentum before and after any event. In an elastic collision, it is said that the momentum and the energy both are conserved since there is no loss of energy after the collision. Is air momentum a force? We know that the Newton's second law deals with the rate of change of momentum in a particular system that is under any motion, whether it is linear or angular for that case. According to the law, we know that aerodynamic force acting on the body under motion is directly proportional to the momentum with which it undergoes motion. Indeed, even if it is not related in any kind, there is a dependency on the force for an air momentum of a fluid. In a fluid, the aerodynamic force generally is equal to the momentum as such. There is basically a lift that happens when the air is deflected, and so when the momentum is considered, it will be due to the change in speed of flow of liquids too. Let us consider an example to understand better the concept of air momentum and its relation with the force. In modern cars there is a safety thing called airbags. These airbags help in reducing the effective force when an accident occurs. This way, change in momentum too is a factor that helps in reducing the effective force when the speed accelerates. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.